Good afternoon, everyone. It's very nice to have you all here, and how many people actually are to be discussing about rebound effects and the launch of Reboundless. So please be welcome. My name is Daniel, and I'm a postdoctoral researcher at DTU, and I'll be hosting you for today. Yeah. So I'll be guiding us on the launch today. And to start, I would invite you to look at this picture, look at this image of Earth, and try to make sense of what it means and what actually is happening right now, right? All the Earth systems and also us human beings and all the other beings, all the systems and boundaries that it means. And actually, if you really think about it, it was only in the 60s that the first person actually could see it as a whole, and also the first images from Earth. And I was reading quite some yesterday about what that meant. But the idea of holiness, the idea of being finite as well, being limited to, right? And I think it's by, it explains also that already in 72, we started realizing that it was very finite, right? That if we kept consuming as we were consuming, and also population growth and so on and so forth, we could reach the limits to growth, right? So even if we have access to pictures and this connection that I really think that this image brings, and also the idea that it's limited. If we fast forward to now, 50 years roughly afterwards, we have plenty of evidence that we are reaching, that we are transpassing 6 out of 9 of the planetary boundaries, right? And I know that if you are here, probably I don't need to be lecturing you too much about that. But I think it also puts in perspective, and it's important to connect ourselves and know that we have plenty of challenges ahead of us, right? And what I understand that the discussion today will add in those challenges that we have, circular economy, sustainability transitions, energy transitions, all those challenges, is that even if and when we actually manage to get everyone on board, we actually manage to design the solutions, we actually manage to implement that solutions, which takes quite some effort, we might still encounter rebound effects. Right? So I think we add on the discussion on how we should think about rebound effects and how we could be proactive in them. I know that many times I expect that you had many different connections to this kind of talks, and sometimes you have this paralysis feeling. But I think by addressing it, it's our way of being proactive and actually thinking about rebound effects before they happen and addressing them before we encounter them, right? So with this image, I would like to welcome you all and just address all the kinds that we have here. We are all individuals, and we all I expect we have a relationship and do our best to keep it, but also we come from many different places and we do our best effort on our day-to-day activities. So everyone from industry, thank you for being here, very welcome. People from consultancies as well, helping industry, helping on the transition. Public authorities, policy making, it's very important. DTU students and representatives, and also members from the other universities. You are all very welcome here today to discussing with us. And of course, people online, right? I should not forget that we had more than 200 people that are attending online, and quite some people over here, so you're very welcome for today. So our goal, as I said, is to raise awareness about rebound effects and drive the discussion. So we have the program for today, some blocks. It is designed in a way that we will start learning a bit more about the strategy of DTU and how sustainability is important, is an integral part of DTU's strategy. Also, we'll hear a bit more about rebound effects, definition, what it means, and so on. And then we have plenty of time for discussing the state of the art in terms of rebound effects, from terms of absolute sustainability, public policy, and also the role of design in setting the scene. And then finally, we will show you a sneak peek of Reboundless, the project, how we intend to go about it. And at the end, we have time to network. I hope you all enjoy the day today. You're very kind. Thanks. So to start with, I would like to invite Nørgaard Hansen, and he will bring us the discussion on how sustainability is an integral part of DTU and how the students and also how we bring the discussion to society. So Hans, please be welcome.
Thank you. I would also like to welcome all of you to this event. I think it's the first time I ever have had more than 300 people attend a kickoff meeting for a big project. So I think it is, let's say, a result of the topic, but also of our project manager, Daniela, and very much a big tribute to her. And of course, we are very happy to have you and the project at DTU. So DTU's strategy for this current period has the title Technology for People. When DTU was founded in 1829, the founder, a guy called Hans Christian Ørsted, that you might know for the discovery of electromagnetism, said that DTU should be using natural and technical sciences for the benefit of society. And this is today even our guiding star. Technology for People has been broken down into sort of 3 goals. And one goal is about technologies for sustainable change. So all researchers and teachers at DTU have to relate to the fact that sustainability is important and how they want to contribute to the sustainable change of society. One of the initiatives that was launched last year was our Center for Absolute Sustainability, which is a cross-DTU initiative, but with 2 main participating departments and also a management group consisting of Professors Michael Hauschild and Tim McAloone, about how do we make sure that sustainable solutions are actually sustainable from an absolute point of view? How do we take these planetary boundaries into considerations? And of course, the Reboundless project, the methods, the thoughts behind it is an extremely important part of this activity. In the center, there is a big attention also from industry and other academia to make sure that we move in the right direction. And also from the top management of DTU, this center has a big focus. To give you an example, which is quite extraordinary, DTU sponsored 10 full scholarships for PhD students to support the development of this center. And in my time at DTU, this hasn't been seen before. Just to give you an impression about the importance of sustainability at DTU. Also at department level, sustainability is very important. So this is a picture imaging some strategic goals of my department, the Department of Civil and Mechanical Engineering. And from a situation perhaps 10 years ago, sustainability was nice to have. Now it is also in the minds of our colleagues need to have, and everybody contributes with whatever they are able to contribute with. So we have colleagues developing new solutions for engines to make use of green fuels for big vessels. We have people looking into sustainable design of products and commodities. And then, of course, we also look into how sustainability affects civil engineering and building construction industry in general. What Reboundless and the activities of Daniela is sort of bridging would be methods that go across the different disciplines here, so that we are actually able to bring these methods into play no matter what technical area we look into. And I think this is quite unique. It is also, in my understanding, not an ERC project granted under the technical sciences, but more social sciences, which is very, very interesting. And I hope it will really bring forward the department and the sort of ability of the department to work with these methods. With this, I would like to welcome you to this event. I hope you will get a magnificent time, I'm sure. I have seen the program in detail. You can look forward to that. And I hope you will come visit us, Daniela in particular and Tim, but the department, you are always welcome if your way goes by DTU. Thank you very much.
Thank you, Hans. And by watching it now, it's just very nice as a researcher that we have sustainability as an integral part in DTU and the whole department. So it drives us too. Thank you very much. So we move for our next guest, or our host, Daniela. She will talk a bit about rebound effects, a brief introduction about the team, and also the reason that we are all here. So the hands for her.
Thank you very much all for being here. It's more than a dream to have so many people here today. But before we actually start talking about the project, about Reboundless, it's really important for us to talk about rebound effects, to understand what they are, why they happen, and actually what we can do to prevent them from happening. And for doing that, I'm actually bringing my story into how I started working on rebound effects. And I am an environmental engineer by background, and I always wanted to find a way to minimize the environmental impacts before they happened. I started working with sustainable design as the way to move forward. And today, I don't need to convince anybody else that sustainable design is the way to move forward. Actually, if we look around us, there are sustainable solutions all over the place in all different areas that we can imagine, from mobility to nutrition, housing, consumables, and so forth. So many brilliant examples out there just now as we speak, trying to understand how to enhance the overall sustainability performance of our systems. And if we look at the EU only, this is the amount of money they are planning to invest on sustainability from 21 to 2030. Did you manage to count all the zeros already? It's 1.75 trillion euro in investment on sustainable solutions. That's amazing for all of us working with sustainability. But what happens is that usually when we have sustainable solutions, we start behaving in a very strange and unsustainable way at the same time, which actually leads to rebound effects. And that's what we'll be talking about now with one example that is actually a real one. A few years ago, I was in China. It was just before Corona. And there was a conference about the cool Earth. So how can we minimize carbon emissions so that we can live within the planetary boundaries in terms of CO2? And I met a guy from one of the car sharing companies that is quite mainstream here in Europe, but also in many different parts of the world. And he was basically making a beautiful sales pitch about bringing this car sharing system to China and really bringing that in scale. And we were discussing that, well, if you look at a car ownership point of view, we actually have loads of resources that we are not actually using. A car, a traditional car, is usually running from A to B for only 2% of the time. It is 95% of the time parked, and the other 3 we are actually looking for parking, but we are actually only moving from A to B for 2% of the time. And then the argumentation was beautiful, right? Imagine if you could have a car sharing system where instead of the car being used by only one person or one family, we could actually have it shared by more people. And therefore, we would need less cars to fulfill the same mobility needs of more people. Brilliant idea. Changing of business models and trying to understand how we can provide access of products to more people at the same time. And then I asked this guy, could you tell me a little bit more about the lifetime of the car when it is in a car sharing system? And then he said, well, you know, if you have a traditional car ownership, usually it lasts for 10 years, so about 200,000 kilometers. But when we put that in a car sharing system, and he said, this is something that we are really trying to work on just now, but the lifetime goes down to only 6 months. When he told me, I said, oh, I'm sorry, I think you didn't understand my question. Let me ask it again. They said, no, that's right. The lifetime of our cars today in our car sharing systems are only 6 months or 60,000 kilometers. Yes, the cars are used by more people, but people don't really take care of the cars as they would if there was their own ownership. But the cars were also not really designed to be put into this car sharing system. The requirements are simply different when you move from ownership to shared systems. And this actually means that instead of using less cars in car sharing systems, we end up using more cars to fulfill the same mobility needs. And this can be even worse if, and the difference here is, of course, the rebound effect, right? More cars instead of less cars, when the idea was actually to be able to use less cars. But it gets even worse, and we might need even more cars, depending on what the car sharing system is substituting. Because if it is substituting walking, cycling, or public transportation, then the rebound effect actually gets even bigger. We had all the good intentions. We had a good solution that we thought would help us to achieve those expected sustainability outcomes. But because of rebound effects, we actually have a worse situation in this case than we had before. And then I thought, okay, there might be something that we can do about it. How can we use our knowledge on how to design the best solutions in the world to prevent those rebound effects from happening? Because some estimations today show that rebound effects undermine about 40% of the overall sustainability gains which means that from these 1.75 trillion euro that Europe is putting on sustainability, we'll be losing 700 billion euro simply because we don't manage to be effective in the design of sustainable solutions that we have. And then the question is, really, how can we build upon all the sustainable solutions that we have out there and that we are all helping to design today to actually achieve the sustainable benefits that we need them to achieve so that we can live within the planetary boundaries? And that's what we're going to be discussing today. Thank you.
Thank you very much, Daniela. And I really think that coming up with an example is a very smart way of explaining rebound effects. And maybe this is one of the examples that when someone also, what is this thing about, we can use also the car sharing as an example to explain what it is. This is very powerful. And then we move into the second part of today, where we will be setting the scene. We're having some important discussions, or actually how rebound effects is being discussed from many different perspectives. We'll look at it in terms of absolute sustainability. We'll look at it in terms of public policy, and we'll look at it in terms of design. So as our first guest, I would like to invite Serenella Sala.
Thanks a lot for inviting me to this launch and to reflect on this important aspect of the rebound effects and their role as contributor or as potential constraint when we want to achieve absolute sustainability. I'm working at the European Commission at the Joint Research Center, and I will bring some elements of reflection in relation to the use that we are making of certain approaches and methods to try to address elements of the rebound effects. So the work that we are doing is basically trying to answer from a policy angle on the question on why rebound effects are important for sustainability and which are the implications and the risk when we are not considering those. Daniela already illustrated with a very powerful examples, but of course there are additional elements and concern. And so I will give you a brief introduction from the point of view of the policy needs in terms of addressing rebound effects and the role that life cycle assessment is now playing or is expected to play in helping addressing a specific aspect of the rebound effects. And then I will share with you some conclusion and outlook that I think will be important to shape also the activities that will be conducted in the projects. So as I said, I'm coming from the Joint Research Center, and I'm just repeating this because we are really focusing our research on the support of EU policy priorities, and the Green Deal and the ambition of green transitions is really one of the 6 political priority, with numerous policies that are really fostering the sustainable solution that Daniela mentioned. And specifically, I'm coordinating the activities of the European platform on LCA, where we are really trying to see how much integrated assessment approaches like life cycle assessment can help not only to quantify impacts, but to contribute to a cultural shift which is needed. So a shift in really a way in which we are addressing the burden and benefits associated with policy initiatives. So an integrated manner to see the environmental, the social and the economic impacts of a policy initiative, but also the consequences, the unintended consequences of certain actions. So the example could be, we can invest for sure in a policy initiative which is aiming at reducing our climate footprint, our carbon footprint, but on the other hand, we cannot neglect that we might have other aspects, other trade-offs in terms of other categories of impacts, or that we are potentially generating at micro scale or macro scale changes, systemic changes, which are leading to these unintended consequences. So it's really part of now the set of tools and methods that are proposed for the so-called better regulation, the use of integrated assessment approaches. And life cycle is one of those, and it's not for sure the unique, but is the one that can easily interact and contribute with others approaches and methods to define in an holistic manner what is associated with a policy intervention. Now, in relation to rebound effect and sustainability science, there is in literature already a vivid debate on how to quantify this rebound effect, where they are occurring. And actually, the evidences are that certain policies associated specifically with resource efficiency, and these include circular economy related policies, are particularly vulnerable to rebound effect, because the increased resource efficiency may lead to certain behaviors in terms of, yes, I have something which is more efficient. Maybe I have also a cost which is reduced, and then I consume more, or I'm less interested in having a maintenance over time of my product because I just buy a new one. So it's really a great variety of different type of rebounds in terms of the different economic actors, from the individual consumer to other economic actor at micro scale that might then be the agent of this rebound effect. So as I said, life cycle assessment is now helping us to unveil certain aspect of these rebound effects, and is helping us, being mentioned already in many policies of the Green Deal, as an approach that can help unveiling trade-off, but also unveiling unintended consequences. And this is not just for the circular economy, but also for the farm-to-fork, for the chemical strategy, for the zero pollution, for the biodiversity strategy, and so on and so forth. And the Commission, the European Commission, has a set of tools, and I wanted with this brief speech just to mention one of these tools that it's now helping us exploring this issue of the rebound effects. So basically, the Commission is implementing the life cycle thinking and assessment via the environmental footprint, so the comparison of products based on robust rules and robust methods and approaches for the comparison, but also using LCA at macro scale. So understanding the consumption and production patterns and their evolution over time, both with a perspective which is just looking domestically what is happening in a member state, but also with a focus to consumption, so addressing also what is happening along the supply chain. And this is accompanied also with a tool which is called consumer footprint, which is helping understanding the individual impacts. What is the consumption footprint? Basically, the consumption footprint is a systematic evaluation of the environmental impacts associated to 5 areas of consumption: food, mobility, housing, household goods, and appliances, considering representative products that represent that area of consumption, multiplied by the consumption intensity, so by statistical information or other type of sources of information to define what is the pattern and what is the evolution. And the idea of this consumption footprint, which is in a platform publicly accessible, is to assess then 16 environmental different impacts, which are the impacts that are also used in the environmental footprint methods, but also to make an additional step. One step is to compare this impact against the planetary boundaries and to assess these impacts in terms of SDG, Sustainable Development Goals potential achievement. So now, why we need an approach that is addressing rebound and in the context of absolute sustainability? These start from a consideration. There is a long-standing tradition of focusing on decoupling concept. To say we would like to have economic indicators or well-being indicators increasing over time, and this is happening in Europe, notwithstanding some stagnation, overall we are growing, to have a decoupling of these economic indicators from the impacts. So we are pretty good with the domestic policies to have certain impacts reduced. So this trend that you see here, which is a single score of the 16 impact categories that I showed you before. But when we start looking at the consumption footprint, so including what is happening to, for example, the impacts associated with our import, the situation changes a bit. So the decoupling is not so much happening. But then when we confront this apparent decoupling with what is the situation of the impacts of consumption against planetary boundaries, we end up to see that basically we have a situation of overcoming significantly many planetary boundaries. So some key consideration on assessing the rebounds based on this consumption footprint approach. On one end, that we cannot consider one environmental impact category at the time, because every area of consumption has a different contribution. So like the green that I hope you can see is the food. And if you see across the impact categories, the relevance of the green is different. So to address environmental concerns, we have to look impact category by impact category. On the other side is we might have green transitions or alleged green transition that might have trade-offs. So very good on many impact categories and then having trade-off in others. And we cannot neglect this. But also that we have to keep in mind, which is the evolution of consumption over time. So I just give you another example to conclude, to say, for example, in relation to the eco-efficiency, we had certain green transition expected in consideration to the appliances, to electric and electronic device. And if we take a baseline over time, actions on these appliances were able on the different impact categories to show a certain reduction. So the eco-efficiency measure seems on a good track. But then we can see with additional circularity measure, what is happening. In some cases, we have actually a reduction. In other cases, the reduction is pretty negligible. But then we can look at technological changes that are happening, not only in the products, but in the supply chain. And again, the situation is pretty different impact category by impact category. And then we may look also of how this consumption pattern evolution is affecting the picture. So if the combination of all the previous intervention were able to keep us below the baseline, basically the evolution of the consumption of certain categories of products is already offsetting these benefits. And this is one of the elements that with the rebound, it's important that we take into consideration. So the full combination at the end is positive for certain impact categories and for others not. And I conclude just with one warning that also the scale of the analysis matter, because on one end, we might expect from certain intervention a very good outcome at macro scale, For example, if we do an increased recycle of certain material, like of PET packaging. But then when we look on the macro scale to the entire supply chain of the relative contribution, something that seems very, let's say, useful in the micro scale is actually pretty small in the macro. So I stop here. I hope it was useful. And of course, I'm available for further discussion and for answering any question.
Thank you very much, Serenella. We got space for a couple of questions. If anyone in the room would like to shoot a question. Else I can start with one and then we have time to think. Serenella, very impressive work in terms of quantifying the rebound effects and getting a glimpse in the terms of macro level. I would be curious on how you see the European Commission influencing the prevention of rebound effects, how specifically it could influence. Just hinting, we have been seeing that it has been part of some of the Horizon projects, that in order to apply, you need to indicate how you will actually measure or try to influence rebound effects. So how do you see Europe and the European Commission influencing on measuring and maybe preventing them?
Yeah, I think you mentioned already one action, which is on the research and innovation, so supporting the development of methods. And I really hope that this project will, try to understand and what can be also the policy needs of the methods, so in their dissemination, to avoid any lag between the research results and the applicability in the policy context. Because on the other hand, what I mentioned before, this better regulation toolbox, so the Commission is really taking very seriously the step that is called impact assessment, where the different policy initiatives are the options for policy initiatives are evaluated one against the other in terms of their performance. So I see that there is already mention of this type of effects as effects to be detected, and there is room to expand the toolbox for the better regulation to ensure that this kind of conceptual approaches become something that on the quantitative side are more and more robust and can help, especially thinking that when we are discussing a policy initiative, we are thinking on a time frame that is on a relatively mid-long term. So there are aspects that even if not quantified with the precision that, of course, the fact that we are thinking about 5-10 years ahead is hampering. But on the other hand, tools that are helping to detect what can be a possible rebound, in which area we might expect the rebound, because this means to put in place policy initiative together with possible mitigation actions to avoid the rebound or to minimize the rebound.
Or two more questions. Otherwise, I have an extra one. There's one in the chat.
Yeah, I saw it. I can reply. Actually, maybe I was not clear enough in my explanation. Basically, we have in our platform both the geographical based emission, so those that are country by country happening in relation to a number of emission, and that is for us the domestic footprint, while this approach to consumption, which is basically the apparent consumption, so the correct for import and export, is what we call consumption footprint. And the idea of keeping both was really to be very vocal also with our colleagues that are dealing directly in the development of the policies on the difference that you have if you are looking at what is happening, for example, for the CO2, but also for other categories of impact, if you just look domestically compared to what is happening if you take into account the supply chains. So this is really the essence of the exercise, was really to make this comparison very, very clear, because the difference is pretty striking.
I have a final one. Yes. Building upon your knowledge and your extensive work in impact assessment, and you mentioned a bit in terms of being able to assess over time and all the other aspects or the complexity of addressing rebound effects. What do you see in terms of the tools available, how they enable actually to foresee those rebound effects, but also maybe the shortcomings building upon your experience?
Yeah, I see a lot of potential in the integration of different modeling approaches, especially those that have a more biophysical nature or engineering nature, and those that have an economic nature. And we are conducting this kind of exercise really not with the idea that the numbers should converge at any cost, but to see how the results may be complementary in helping detecting the hotspot, helping detecting where we have to concentrate the effort to mitigate the impacts. So there are already many examples of integration of supply chain based assessment with economic models of different type. But I think this is really an area where we have to invest more, including with agent-based modeling. Because on the side of the macroeconomic, there are certain considerations that for sure can be addressed, already well addressed, I think. But on the side of instead of behavior of agent, this is an area where personally I think we have to invest more. And again, it's the behavior of the individual, but it's also then the behavior of other economic actors.
Very much. Some claps for Serenella. Thank you so much. It was actually quite insightful and a good connection to our next presentation, as she finished discussing the need to address behavior. And I will invite Jeroen van den Bergh. He's a professor at Universidad Autónoma de Barcelona and also at Vrije Universiteit Amsterdam. And he has plenty of work in policy, in economics, and also complexity. And it's our pleasure to have Jeroen here to talk about behavior rebound effects and their implications for climate policy. So Jeroen, the floor is yours.
Ah, yes, I have to unmute still. Okay. Can you hear me now? Hello? Please some feedback that you can hear me, because I don't hear anything.
Please go on.
Okay, I'll start, and if you don't hear me, I'll notice it. So my name is Jeroen van den Bergh, and I will talk about carbon rebound and climate policy, and especially focus on the systemic and behavioral aspects. First of all, I would like to say that I am honored to be invited to speak at this opening meeting of the Reboundless project. And especially, I would like to congratulate Daniela Pigosso for obtaining a prestigious grant like the ERC grant. Like her, I believe that dealing with and limiting with the problem of rebound is essential to get good solutions and ultimate solutions to environmental and especially climate problems. So if we talk about rebound, and I want to talk about carbon rebound, because I want to focus on climate change, it's important that we have agreement on a good solution. On a good definition. So my definition is that carbon rebound denotes potential CO2 emission reduction of adopting an energy efficient technology or practice that is offset by subsequent behavioral and systemic responses which increase energy use, resulting in diminished net energy and carbon savings. It's important also to mention practice here. It's not only about technology. Even if people undertake voluntary restraint or sufficing behavior, they may, because of available income, they may rebound to other areas of consumption. Now, in order to understand rebound and solution to it, I think it's important to see the fundamental reasons for it. So I identify 4 here. First, if you improve energy efficiency, you effectively relieve resource limits. And this in turn means that activities and associated energy use can grow. Secondly, if you develop more efficient general purpose technologies, that means technologies that have a widespread application in many sectors and activities, then you stimulate their diffusion. So you can think in this respect of engines, batteries, light gear, transport vehicles, etc. But also new composites or materials that are improved in terms of their efficiency in production may then end up in a widespread application. Third, we see that efficiency improvements often create more technological complexity. For instance, to make engines more efficient, you can include an extra cycle. And also at the higher level of multi-sectoral activities that produce services and goods, you see that the product chain tends to become more complex. Life cycles tend to get longer. And in fact, the embodied energy over the whole life cycle may, because of that, be increased. And that's rebound. That's one form of rebound. And fourth, consumers and firms show bounded rationality, like myopia, habits, partial goals, compensating, environmentally friendly decisions. So despite good intentions, they may not achieve the energy savings, the carbon savings that are potentially feasible. Now, the reasons that I mention here under 1 to 3 can be seen as systemic effects, and the fourth evidently as behavioral effects, and that's why I want to give attention to both of them. So this graph illustrates how rebound works. So to the left, you have energy use. You can reduce energy use as indicated by the green arrow downwards, but then there may be all kinds of unexpected, unintended effects that limit your ultimate energy reduction. So direct rebound means if you take the car as an example, an efficient car, that you use a more efficient car more often because you realize that the car is cheaper in use. But if you save energy because your car is more efficient, you might also save money, and that money might be spent on other goods. This is called indirect rebound. And then because of that, and because also you buy new technologies, you might stimulate changes in production. That's what contributes to so-called economy-wide rebound. Now, the effect here is that the original potential savings are reduced to the green part. So the red part is what you lose. In this case, it's larger than the green part. So there is concern for rebound. It's a relevant issue. What we see from many studies is that typically economic mechanisms play a role. Income spending effects, factor substitution, competitiveness changes, market interactions, and also at the international level and at the macro level. Financial labor markets interact with goods markets, trade and relocation play a role, and technological diffusion, of course, is an important factor. So what you can learn from this is that the overall system that you try to regulate is complex, may also change over time, has a lot of feedbacks. And this is a challenge for empirical research, and means that the magnitude of rebound is estimated in many studies. And Daniela already said that on average is 40%. Well, that there is even evidence that might be higher at the macro level, but there is uncertainty. Add to this also that many of the empirical studies observe a limited period of time, have spatial limits, and don't cover a complete system usually. That means that rebound is easily underestimated. Now, I already said economic mechanisms play a role, and not surprisingly, prices and cost play also a key role in understanding rebound. And here's an illustration. So you see 3 energy carriers and estimates for different countries of rebound of energy saving. And you see that for gasoline, rebound is on average much higher than for natural gas and electricity. And that is because gasoline is a global market with relatively high prices for developing countries, whereas natural gas and electricity, often based on coal, have lower regional prices. You also see that among countries, if you take gasoline, there's a lot of diversity, and this is triggered by 2 factors importantly. First of all, existing prices, usually influenced by existing taxes. So, for instance, Venezuela and USA have very low energy taxes, and carbon intensity of the economy. And you can see on the right side that China, for instance, has a high carbon intensity because it uses a lot of coal. So if there is a rebound in energy terms, then in carbon, it will be even stronger. Now, these 2 dimensions of systemic and cost dimensions, they suggest that you need a policy that deals with both of them. Now, many people are very strongly in favor for direct regulation through technical standards or stimulating behavioral change through adoption subsidies. But both of these tend to reinforce rebound. Standards, for instance, they stimulate that people buy more efficient products and technologies, but they don't control the user phase, and the rebound happens in the user phase. Adoption subsidies are even worse, because adoption subsidies make technologies more cheaper for the adopters. Therefore, there's a bigger monetary gain, which then can stimulate more rebound. Of course, you also have a situation that there's a lot of technologies in the economy. So with standards, it's very difficult to cover all of these. Now, in order to have a systemic solution, you need to cover the whole system. Now, one instrument that in the literature has been analyzed and suggested to work well is carbon pricing, because carbon pricing is a systemic instrument. It tries to cover the whole life cycle and production chain. So if you buy a product, you will effectively pay a price for all the energy use and carbon emissions in the whole life cycle. And so you can be myopic, you cannot understand that maybe, but it doesn't matter. The price will drive you in the right direction. Of course, what is essential also to pricing is that it undoes the cost reduction of energy efficiency that drives rebound. So here you have both the systematic and the cost correction, which is needed for a good solution to carbon pricing. Among carbon pricing solutions, cap and trade is particularly effective because the cap assures that you never will exceed a certain amount of energy use or carbon emissions. And in fact, if there is a tendency to rebound, then the price of the cap and trade system or the carbon market will increase until energy use and rebound is within a limit. Of course, the problem of reality is that we don't have such carbon pricing in place. The best system we have is the EU ETS, which only covers like 50% of emissions in the EU, only the large emitters. So there is a risk that rebound will occur to the smaller emitters. And in order to avoid that, the EU should cover the whole system. And fortunately, it has plans to do that. Now, regarding the behavioral factors, these complicate matters tremendously, because look here, behavior plays a role through a cycle of effects. So you start with motivations, then there are moderating factors. Finally, there's decisions, and these decisions trigger a rebound. So at the level of motivations, two elements play a role. First of all is whether individuals are very selfish or not, and whether individuals are socially motivated or morally motivated. At the level of moderators, bounded rationality and bounded willpower play a role. Bounded willpower means that people cannot control themselves, that they are very myopic. Therefore, they may have preferences to do something, but these preferences may not necessarily translate in actual decisions. And at the decision level for rebound, three types of decisions are important. Adoption of more efficient technologies, intensity of use of these technologies, and respending, denoting that if there are any monetary savings left, how are these spent? Now, there's evidence for the behavioral impacts on rebound, and here you see a summary of those. So bounded rationality and willpower especially tend to increase adoption and increase rebound, indicated by the red cells here. For respending, results are less clear. There's also little research on it, actually. If you look at mental accounting, that's an interesting example. So the idea of mental accounting from psychology is that people have different accounts, mental accounts, for different decisions related to monetary expenditures. And evidence shows that, for instance, if people save money in a transport account, then it will stay there. So if people save money on the car, because they have a more efficient car, then they will just use more transport. A similar thing has been seen with time. If people have faster means to have mobility, then they will travel longer distances. So I will look in a moment about how we can deal with this. But you see here also that we have bounded self-interest, and there everything looks green or uncertain. So it's a little bit more positive story there regarding the effect of behavior on rebound. Now, next to the systemic policy of carbon pricing, we can introduce additional policies to deal with these behavioral biases. Regarding mental accounting, for instance, we should try to make sure that individuals somehow don't use the money that they save with a more efficient technology. And for instance, the house warming, it's been suggested that a smart meter adapted to indicate the days left for the initial investment to be paid back is a way to do that. People then will try not to spend that money until maybe this period has been exceeded. So in conclusion, I want to say that systemic policy controlling indirect and life cycle effects is essential for limiting systemic phenomena like rebound. Cost and prices are key, and that's logical because we're talking about energy saving in effect. So 1 and 2 implies a role for carbon pricing, notably cap and trade, as effectively that will cap all rebound. Of course, bounded rationality and willpower complicate the picture, and therefore additional instruments to address life cycle information like carbon pricing and eco-labels and investment versus user cost like smart meters are essential. Social information about what peers do can help, but might also have the opposite effect. It might, for instance, encourage status-seeking consumption. So I thank you for your attention and give the floor back to the organizers.
Thank you very much, Jeroen. To start, I will ask you if you can open up your camera for the questions and answers, so we can see you during the questions. I would invite anyone who'd like to ask a question. Yes, I will bring the mic to you.
Thank you for your nice presentation, Jeroen. My name is Leah from the University of Copenhagen. I'm actually not from the energy sector, so I'm interested how your estimations are, if those especially social effects and information, what you showed, could be related to other sectors and area, for instance, the food system.
So I'm not 100% sure if I understand the question. So let me try to argue a little bit about that. So the question is with regard to food, if people are very much influenced by what others do, or whether the influence is more what is being offered in shops. But I can imagine there is a group of people who are very much influenced by others, and so you could investigate different groups of people with different food habits and see if these groups are growing and what is the reason for that. I'm not aware of studies in this regard. I'm sure there are so much happening. And I think also it would be feasible to do this because people are quite aware of the choices they make with regard to food. But people are not so much aware about, let's say, the rebound effects of changing food choices, because the production chains are complex, from farmer to manufactured product that appears, and also taking into account all the packaging. So I can imagine people are not aware of all the indirect life cycle effects. So that's an interesting topic for further research, certainly. I hope this answers your question.
Yes, there was a yes. It addresses the question. We have space for one more question. You had one, Elise? Yeah.
Sure. Okay. Yeah, my question was pricing as a way of reducing carbon emissions. And you touched a little bit on this, but I was hoping you could elaborate. We see a global rebound effect when a cap and trade system or a carbon tax is implemented in one country, and then multinational corporations move production or their capital to less regulated countries. You mentioned that the EU is working on a more systematic cap and trade system policy. I was wondering if you could elaborate a bit on that, or share your insights into how to prevent this global rebound effect from occurring.
Thank you. That's a very good question. In fact, I had a slide on this, but because of the length, I had to remove it. So I'm also very much worried about that, because life cycles and product change are very international. They're not bounded by national boundaries, national frontiers. So in fact, for that reason, I think we need to harmonize policies internationally, regardless whether it's carbon pricing or other policies, because if there's policy differences, this will trigger changes in trade flows, which then lead to rebound, or it will lead to even industries or plants of industries moving to other countries with weaker policies. And in that respect, I think there's also something to learn from the EU, because the EU is basically the only region in the world that has a harmonized policy through the ETS, through the emissions trading system, among all its member states. There's really no other example of this. And what is also interesting is to look at the recent period with high energy prices due to the Russian invasion in Ukraine, and many energy taxes and energy levies were cancelled or lowered in a period in many countries, but the EU ETS was not touched. I don't know why that is, because it's not on the people's minds, or because it's supranational, it's very difficult to touch. I think it's a bit of both, but it also shows that supranational policies have a great future. So I personally think that we can only solve climate change anyway by harmonizing policies, by having, I think the EU should try to make a deal with the US and create a kind of emissions trading system among those two partners. And maybe in the longer run, China could join, because China, in effect, has already an ETS system, which is different in style and nature, but still it's an ETS system. And if those three would combine their forces, then all the other countries would want to join, because you wouldn't want to be outside such a system, of course. And the final comment is that, of course, the EU has also decided, or has already implemented now, or is starting to implement, a carbon border tariff to protect its own policy. And that's like a second best option to make sure that you don't have rebound or not too much rebound effects across borders if other countries don't implement good policies. Thank you.
Thank you very much, Jeroen, for your contributions and for the insights into policy and behavioral aspects in rebound effects. I invite everyone for clapping for him. And now it is much of a pleasure to invite Tim. Tim, you have been contributing to integrating sustainability into design of products, product service systems, as one of the heads of the Absolute Sustainability Institute, and also from the Design Society. So it's a pleasure to have you here to address us on the role of design for us achieving sustainability, and also the role of rebound effects.
Thank you, Daniela. Wow. Thank you, Danielle, and good afternoon, everybody. Really nice to be here, and I'm really honored to be here and also bursting with pride to be at your launch event for the Reboundless project. Yeah, I've spent a lot of my career teaching or preaching about sustainability to designers. Now I'm going to spend this presentation preaching design to sustainability people. So I'm actually going to spend my time here talking about what design is, because this Reboundless project is about actually how do we design solutions which have no rebound effects in them. It's funny, we're playing with the internet still after some training with being online and offline and hybrid, and we're finding lots of difficulties. And it reminded me of a story, actually reminded me of an event. Yesterday was a big day, the 3rd of May. Anybody guess what it was? 30 years since the World Wide Web was launched. 30 years. And 29 years and 8 months ago, I started my PhD in this area. So there were not many online systems. And all of the design which has gone on since, all of the developments of the internet, just to take one thing, they've been designed. Some of the things have evolved, but design is key to the way in which we run and live our societies and our lives. And design is about sense making. It's about taking an idea and putting some order into it. And it's about putting that order into action to get it ready to be implemented. And with all the best intentions of the world, we can make very good designs. But if we don't think about everything that could go wrong, we may create rebound effects. I'm going to take the analogy of mobility and transport for most of the presentation here. And can anybody guess what this is? Yes, it's from Harry Potter. But it's actually the Glenfinnan Viaduct. It was built in 4 years, from 1897 to 2001 to 1901. I was looking out at the light railway building just before. It's on its 7th year of building. So it took 4 years to produce this. Made of mass concrete production, so pouring mass concrete into molds. Not one piece of steel or iron in the structure. It's 380 meters long, 5.5 meters wide, has 21 arches of 21.5 meters diameter. And they made this at the end of the 19th century. This was designed. And the mobility system on top of it was designed too. If we look at other parts of the world, the way in which our world develops may sometimes evolve, may not look designed, but there's plenty of design here as well. This is the Meklong market and railway in Thailand. This is the train just leaving, and the market reappears and reemerges. And there's plenty of design in here as well. The way in which all the market stall holders put the canopies up, take them down 4 to 8 times per day. They've designed solutions to fit into smaller and packed spaces. This is also design. It's not design of a product, it's design of infrastructure. Very well thought out, apart from the rail track that goes all the way from the other side to this side. That must have been a difficult one to make. But infrastructure is also designed. And on that infrastructure, many different types of design, technical, technological design. This is the trains system in Beijing and the parking space at nighttime, heavily influenced by the Shinkansen, the TGV, and others, with a host of different types of designs implemented in an extremely short time. This is also design. It might not be accurately like the map of Sealand, but we can recognize it. And this is actually taken from a dominant design by Harry Beck from 1933, who designed the map for the London Underground system, which has become a dominant design that makes it easy for us to navigate wherever we are in any rail system in the world. That's what it looks like to you and me. But to the guys who need to run the system, this is the design. This isn't Copenhagen. This isn't the S-train system. This is in Mumbai, the design of an extremely complex system. Talk about digital twins. This is a digital twin of the whole rail system of the Mumbai, with, it looks like just one guy running it. I don't think that's quite true. Remember these? These used to be tickets. It's a type of a currency that was designed. And then we designed a whole different socio-technical system. We had to learn to check in and check out. How many had very many fines in the first 6 months of having these? Has it got better since? Yes, because we learn. And design is about designing the system and also the behavior, understanding the behavior and nudging and making different ways of behaving. And I could go on and on and on. The S trains making more space where we never thought there was space because there's only a small distance between the tracks, but making the belly of the S train go out so we get a better feeling of comfort inside. The rolling stock, the braking system, the suspension system, the signage on the side, the white doors to remind us where the doors are if we hadn't worked out already. And inside, this lady can stand up and read her newspaper because we designed a suspension system that works. You get the message. Design is super important. And basically, we design everything from materials to components to products to the signage to the aesthetics to the system of systems. Everything is designable and everything is designed. In our community, the design research community, we have a few heroes, and this is one of them. This is Herb Simon. He got the Nobel Prize for Economics in 1978. And in his book, The Sciences of the Artificial, he told us that we have bounded rationality. We just heard that from Jeroen's presentation as well. We have something called design science. This gentleman was an economist, a social scientist, a psychologist, all rolled into one. But he was talking about design science. And he says, through this bounded rationality and something called design science, we make good choices. And basically design is about making stuff how things should be. That's our intention, all good intentions. What is design science? In our community, we think that design science can be at least practiced through design practice, of course, understanding all of those examples I just showed you, through design research. That's why we have it as a researchable topic. And of course, through design education. What spells design? If you take the journey 150 kilometers south to Germany and go to any technical university, the Bible for engineering design or engineering designers is the book by Paul and Baines. It's this thick. In the third edition, they made a picture of how they saw engineering design. and how it's situated according to science and engineering science and all the way to production. And on the other axis, more the arts from the arts to industrial design, architecture, and up to even to politics. And then they draw these lines here, which is quite interesting. We see engineering design as the middle of everything. Of course we do, we're at DTU. But actually what they did was to stand in the middle and say, if we look this way, we have respect for the sciences and the engineering sciences. If we look this way, we need to make good solutions ready to produce. If we look this way, we're inspired by the arts. And if we look this way, we know that we're influenced by and influence politics. So this is the, you can say, the bird's eye view of how Harlem Bites see design and the designer's role. If we go across the pond to the US, our good friends Carl Ulrich and Steve Eppinger made this similar model, closer to what you see inside a company. Looks like a stage gate model. The process of going from planning to concept development all the way to the solution, which actually becomes produced at some stage. One of the things they tell us in that book is that the early decisions, they are absolutely vital. The very early decisions, they decide everything. Then there was a guy at Cranfield University who wrote his PhD in 1998, it's me, and he said 80% of the environmental impacts are built into, decided into the product and the design in the early stages. I've been misquoted on that many, many times since. So the early stage is super important. And I've stolen Daniela's overview over different areas and examples of sustainable solutions. I'm just going to take two for you. The first one, slightly away from the mobility example. If we look at this example here, it's a beer bottle. Anybody seen it? The green fiber bottle. This was actually a project initiated by Professor Tom Howard some 7-8 years ago. It was a project run in Denmark together with Carlsberg and a small company, EcoXpac. Produced 3 PhD projects, one looking at the eco design, one looking at the actual design of mold to make a papier-mâché beer bottle, a bottle made out of cardboard, papier-mâché, that can hold 6 bar, that is of biomaterials that can biodegrade, not in the fridge, but exactly when we want it to do so. How do we design that? And then the third one about how to get this papier-mâché through pipes so that we can blow mold it like a plastic, but that 3 seconds after we've made the mold, we need to get the water out because it needs to become a bottle and not a fluid. 3 projects. We managed to do this far, and the company has now been established and made the product much more commercial, available. But then we did a couple of experiments, Daniela and I, with some students, and they thought, what about the behavior? Carlsberg's motivation for this project was they didn't want to have branded waste in the oceans, ocean plastic and branded waste around the forest and so forth. So 2 students did a master's project and took these bottles and said biodegradable on some of them and not biodegradable. They wrote nothing on the others. Took them to a student party here at DTU. And what do you think happens to the bottles? People looked and thought, these are biodegradable, we'll just leave them here. Could be a rebound effect. Back to the mobility systems. Go back to cars. I just learned how to do this yesterday. I'm really proud of myself. Since 1990, we've increased our efficiency of mobility systems of vehicles by around 20%. But that's not quite the full picture because look at this guy here. It's actually become bigger. The cars we produce are bigger, the kilometers we drive are more, and the amount of cars we own are more. Over the 2 years of COVID in Denmark, we actually acquired 15% more vehicles. So if you think there's more cars on the road over the last couple of years, it's true. 15% more vehicles because we couldn't use our money on other things. So the overall effect, the middle ones, it's just slightly worse, but for all that effort to make the technology better, we've got lots and lots of work to do. Maybe because we didn't think it right into the design process from the start. This is a theory that William Jevons thought of in the mid-1800s, the Jevons paradox, that efficiency gains that we get will probably lead to higher consumption. He didn't think about it on these small cars. He thought about it on these things here. By the way, this photograph is only 3 years old. It still runs today, this train. He basically wrote something called the Coal Report in 1865, saying, he's an economist. I have a feeling that the more coal we make available, the more we're going to use, and the more we use, the more we will misuse it, and we'll run out of coal. In 1865, people thought he was crazy. 125 years later or so, 150 years later, we're talking about what that one paradox is one of the rebound effects that we have today. We've talked a lot about the mobility systems, and Louisa, I stole this slide from you from many years ago. I think I can count 8 mobility systems here. If we say that there's a metro system, the regional train, and the S train in the background, we have people's 2 feet, we have cycles, we have sharing systems, and we have private vehicles, and we have a bus, and we have a cycle. 8 possible systems. When we introduce a new system, we create complexity, and we need to think that complexity in order to not increase the likelihood of doing not better, but worse. So to conclude, these are my recommendations from a design perspective. To quote Herb Simon, our hero in design, design is concerned with how things ought to be. But what is the ought to be is what we need to ask ourselves. It's a multidisciplinary professional and activity, as Paul and Bites have told us for the last 20, 30 years. The early design decisions are absolutely vital to effect. So we need to think early into our design processes. All design we do, we can't just design a product or a switch or a material or something. We need to design it in the context that it belongs in order to understand the potential rebound effects so we can design them out. And without this systemic insight, we're probably prone to create unintended consequences, rebound effects. Just sitting back and saying, okay, then let's just not think about it. Not doing design, in my book, is as bad as doing bad design, which is as bad as actually creating rebound effects. So as a segue to the rest of the day, we need theories, we need models, we need methods, and we need tools so that we can help ourselves to design reboundless solutions for society. Thanks for listening.
Thank you very much, Tim. I will start with one question. I have a very burning one, and then we'll have time for a second one. Quite some insight, and it got me the design of what ought to be. But when you talk about rebound effects, we talk about what not to be. How does it change the practice of design or the design process when we try to address rebound effects?
So I hope that you're going to produce lots of insights and models and methods and tools to how to do it. The good news is that the early stages of design cost very, very little. It costs a bit of brain power, some thought, some time, some consideration. And we need to think rebound effects. We need to think sustainability in right at the beginning, just as we would think cost, quality, time, all the other types of considerations into our designs. So that's the good news. I think the tricky news of the challenge, but that's why we're at a university, right? Because we're here to do the difficult stuff and find the solutions to the difficult stuff. If we don't know how to think about the rebound effects and how to think, okay, what could go wrong here? What could be the consequences? What are the patterns we can see in other societal systems? Then we'll likely not think them in. But the good news is if we do think these things in, then we've got a good chance of doing it right.
Great, thanks. We'll have time for a second question, and I had a hand over there. Is it still on? Yeah.
Hi, Tim.
Hi.
Thanks a lot for sharing all your thoughts on design. I think I also have been working with design and engineering and the cross section of that along with business. I think my question to you is that engineering design at large is and design at large has been very anthropocentric. We see ourselves at the center of everything and we're designing everything for ourselves. And there are other stakeholders like the planet, which is often ignored and is a secondary thought in not just the design process, but also in what comes out of it. And we often over-engineer solutions, and simplicity is not something that we seek in design. So yeah, my question to you is, how would you navigate something like this?
Yeah, really good points. And I agree with your points there. It's been for free that we can over-engineer and over-design, and we do it to look after ourselves. So with the best of intentions, if you look at how many margins of error or margins of safety rather we work into our design projects in industry, it's phenomenal how we over design. And that's why we're one of the reasons why we thrive as the Anthropocenes, as the human beings on the planet. But it's another reason why we're actually in trouble, because we do over consume our designs, our structures, our ways of producing things. So I think it's a really important point. And I think that's a nice way to think about what other stakeholders should we design on behalf of or design within. I was just looking to see if he was here, but we have a colleague looking at bio-inspired design. That can show how some solutions can be there that, yes, they may also look wasteful. I mean, nature is also wasteful if you look at an efficiency perspective. But if you look at how nature actually coexists in synergy with other systems, then I think there's some nice inspiration to take there. And I could talk for about an hour about all the different strategies, but I agree that we need to take a step back and see what is the solution, the value we're trying to create, and not just what is the technical system we're trying to produce. Yeah.
Thank you very much, Tim. I'm very sure that we have plenty of more questions, but we have you here, so we can address him. Thank you so much. So we're reaching the end of this first part of our day. I will invite you to take a break, connect to each other. We have refreshments over there. And we actually have prepared for you 2 questions that you could think about, or maybe starters for discussion, right? So how rebound effects may affect your practice or my practice, and how to identify and address rebound effects. We will have posters over there. It's dynamic, so we will have very soon. It's not there yet, where you can put your thoughts into in post-it notes and share with us, right? But anyway, it could be a start on connecting and talking to each other. So thank you very much, and we see each other very soon. So we moving forward to learn a bit more about Reboundless and how we can actually prevent this type of effect. So for that, I would like again to invite Daniela, and she will guide us into the main building blocks of Reboundless. So it's a pleasure to have you here again.
Back again, and now to the rest of the afternoon. And this is to share what are our visions, goals, and dreams with Reboundless. And yes, this is the launch of a project, but actually this hasn't really started today or maybe 5 months ago. It actually started, the first time I submitted this project was back in 2018. And it's actually really nice to see all of you here today, because you've been part of that, directly or indirectly, planting seeds during the lectures that I was giving, or maybe with master and bachelor studies, or maybe with some really interesting questions that I didn't know how to answer. And then I was thinking about them and trying to find a solution. So, and I usually feel much more nervous when I know the people that I'm talking to. That's why my voice wasn't really coming out in the first bit. It's a little bit better now. But, and that's really true. I feel much more nervous when I know people because I feel connection and I really want to be the best I possibly can. And then I fail. But yeah. Thanks a lot, you all, for being here. You are also part of that. And many of you actually helped me to bring this project into reality, either by giving feedback or by helping me in my mock interviews. I actually got 23 mock interviews for my real interview during the day. And I got nervous in all of them, but not in the real interview, which was amazing. And I guess that's probably one of the reasons why I got it. But yeah, Reboundless. This is a extremely ambitious project, which aims to solve this really important issue of rebound effects as one of the factors that are today hindering us from achieving the sustainability benefits that we need to achieve if we are to live within the planetary boundaries. And this project, actually, before I move any further, do you like our logo? Yeah. This is the guy behind it. He is our UX designer. He does an amazing job. By the end of the day, you're going to understand what that means. But we are really proud about our logo, so thank you. But yeah, Reboundless. It is a very ambitious project, which really aims to bring a paradigm shift, both in science, but also in practice, so that we can prevent the occurrence of rebound effects. When doing those mocks and talking to experts on rebound effects, I heard over and over again, no, this is too ambitious. Rebound effects can never be prevented. We just need to learn how to live with them. And I hope they are wrong. And we will actually work quite hard to try to understand what we can do and how far design can actually lead us in this prevention of rebound effects. And I'm going to explain to you how we are actually going to do it. Design, I believe, is a very strong leverage point for achieving sustainability goals and for preventing rebound effects. Design can also create loads of rebound effects by itself. So we really need to be really clever in the way that we use design as a tool to help us to actually live a better life. And one of the questions that I thought I would be asked during my interview was, why design? You should be working on policy. Policy is the big leverage point, especially because I was in this social science panel with loads of economists asking me questions. And I had all sorts of different answers ready for it. And the question wasn't asked at all. So I think it was actually a quite good thing that they can see the leverage point that design can have. And how, so here it's what we promise, right? We promise all of those different things when we write those projects. And this is what we promised and what is our approach for solving these problems. As you might have felt, most of the examples so far, when we talk about rebound effects, they are connected to efficiency strategies. Efficiency are those strategies that aim to help us to minimize the consumption of resources. So minimizing material consumption or minimizing energy consumption at a 1 unit product, usually. It's extremely important. Most of the research today about rebound effects is on efficiency. but it's not the only sustainability strategy that is leading to rebound effects. So what we are doing in Reboundless is also looking to effectiveness strategies. So all of those strategies in which we create more value with less resources. Here we have many examples from a circular economy point of view, from new business models, from sharing systems and so forth. So how do we create more value with this one physical product that we have at hand, for instance? And then we are also looking at a third really important sustainability strategy, because those two, they are mostly connected to production. We are mostly looking into how do we produce and design better artifacts to fulfill needs, but they don't really touch upon consumption. As we saw from a presentation earlier today, consumption is actually an extremely important area to be taken into account. And the sustainability strategy that comes closer to it today is the sufficiency, which tries to moderate consumption and demand of products. And by doing that, we actually expand the state of the art in the research in this field from mostly focusing on efficiency to also looking into effectiveness and sufficiency strategies. And then we go one step forward, because yes, it's extremely important to design products using those three main strategies. We should continue doing that. But products by themselves, they actually do not really help us to solve the problems. We know that it is important to expand the scope of analysis from products only to what we call product service systems, which actually consider not only the physical product, but the service connected to it, the infrastructure and the network, the Mount model, guys, for the ones that took the PSS course. And then finally, as Tim also showed in his presentation, we need to go one step forward and understand how we actually design social technical systems. It's not really about putting this product or this PSS available in the market, but it's about developing systems that can really solve our societal needs. And this requires the consideration of both the technical elements, but also the social elements. And this matrix will be in my dreams and nightmares, I guess, for the next 5 years. And we'll be looking into 4 main areas. When writing the project, I was thinking about maybe I can focus on specific sectors, for instance. But then I thought, well, maybe the sectors don't really need to be there, and the sectors are only there to fulfill needs. So instead of looking at specific sectors, the way we scope Reboundless is to look across 4 main needs, societal needs that all of us have. Mobility, we've been talking a lot about mobility so far. Nutrition, housing, and also consumables. And those 4 areas together account for 3/4 of the global carbon footprint today. So if we manage to find a way on how to prevent rebound effects in those 4 areas, we are already a long way forward, but we can also, of course, use the knowledge towards other societal needs that we have. And it's also, of course, extremely important to consider that rebound effects will not only happen within each area, but if I introduce a change in housing, for instance, this might have an influence in mobility, maybe also in consumables. And understanding these rebound effects running from one need to the other is also extremely important if we are to prevent, to avoid, in a life cycle assessment, we usually say burden shifting, but to avoid changing impacts from one area to the next. Will be an interesting matrix to keep in mind. And of course, I will not be having nightmares and dreams by myself. we really have a interdisciplinary group of people together that decided to dream that dream together with me. And those people are from many different backgrounds, from social sciences, from engineering sciences, and from all different countries. You can see we have 2 open positions still. So if you find it extremely interesting and can't wait, there's a possibility. And actually, the tech guys today, they're part of our team. So big hands for them. They've learned how to use this system an hour ago. And they managed to solve all the problems that came in. So thanks a lot for taking up the challenge as well. And Yendre is not even part of Reboundless. He's the logo guy. And even more so, he's joining us. So thanks a lot again, Yendre. But yeah, we are not alone. Because if we really are to solve this problem, we need to join forces with all other researchers, industry people, consultancy people, government people, foundation people to be able to actually solve that issue. So we are actually building a global network and hosting this network because we don't really want to continue reinventing the wheel as we do in many of the areas that we do research, but we actually want to build upon the knowledge that is out there. And if Jeroen and Serenella are still there, I'm so proud that they decided to join this meeting today because they were 2 of the stars in the area. And I mean, Tim is the local star. So you couldn't say no to being here today. Yeah. And the way we are doing that, it's in a very iterative way. So we are making science, developing new theories at the same time as we are testing them in practice in loads of iteration cycles. We usually say that if the research that we do at the university have no applicability in practice, then it has no value. So it's really important for us to work together with different types of organizations and stakeholders that can actually make the difference, that can use the tools and approaches that we'll be developing to prevent the rebound effects from happening. So I'm also really glad that we have many of you here today that came to actually hear what our plans are. And what we are doing in this project in more detail is to move the current state of the art, which is the tip of the iceberg, from understanding only and mostly the events. So when rebound effects happen, there's this car sharing example that I mentioned to you, but it's only one example. There's the green fiber bottle example that Tim told you, but it's also another example. How can we move away from understanding one example to the next to actually trying to understand why are those effects happening? And this is actually the first part of the building blocks, as we call it, which is to explain the occurrence of rebound effects. So what are the mechanisms that are leading to that occurrence? And how can we systematize them in a way which are reusable and applicable across different cases and across different applications? Explaining is extremely important, but we still need to go deeper in our knowledge. And this is about being able to model and simulate rebound effects. Today, what happens mostly is that rebound effects are quantified after a solution is implemented, but then it's too late. What if we could simulate them earlier on when we are still thinking about how the solution could be? We could learn what could be the potential rebound effects there, and then we could prevent them from happening, which is the final bit. How can we then use all of this knowledge to redesign, rethink our solution so that the rebound effects will not be there? And to discuss that in a little bit more detail, I want to invite Elise, Andrew, to talk about the Explain building block. Elise is a PhD student here with us. She started as a PhD in January, but she's been working with us since October. And you're going to see one of the key results of her project already today, later on. Elise, over to you.
Thank you. Hello. Oh, can I have that? Thank you. Yes. So one of the problems that we have with the existing literature today is that it's focused on estimating the magnitude of rebound effect outcomes or events. And this is great. However, we want to shift the focus towards actually understanding the underlying behavior and the system structures that actually lead to these rebound effects. So there's actually no shortage of studies that estimate the magnitude or the strength of rebound effects. And this is especially true, as Daniela has mentioned, for efficiency rebound effects, specifically energy efficiency rebound effects. And this is probably true because the concept of rebound effects originated within the field of energy economics. And the problem with this is that the traditions, the methodological traditions of mainstream economics relies very heavily on strong assumptions about human behavior, and specifically rational choice models. And just for those of you who might not know what rational choice models are, it's modeling that conceptualize human behavior or decision-making as rational, self-utility maximizing, self-interested, and almost entirely isolated from any external influences. And if you think about this quite intuitively, I mean, this is not how we behave most of the time, not usually how we make decisions. So we need to shift the focus towards investigating the underlying behavior and system structures. And that means actually making other research questions. For example, what are the interrelated elements that constitute the behavior? How does behavior change over time? How can it impact other behaviors? Just to name a few examples. So what that actually means in practice is that we can utilize the insights from mainstream economics, but we need to go beyond that and incorporate other theoretical perspectives. For example, behavioral economics, using concepts like, as we heard today from Jeroen's, probably saying his name wrong, Jeroen, oh God. Concepts like bounded rationality, also bounded self-interest, and so on, or theories like social practice theory. And as Daniela has mentioned, this is we want to take advantage of the rich knowledge that's already out there, and we think we can tap into this, and this is the idea. And to make this point a little bit more concrete, to use an example that we keep coming back to today, not necessarily car sharing, but ride sharing. So a traditional mainstream economics analysis of ride sharing rebound effect could look something like looking at the change in demand for travel, for example, vehicle kilometers traveled, as a result of price change. That is the price change that would come along with ride sharing, so savings in travel. So then it would look at, okay, people respond rationally and self-interested. Therefore, the cheaper the travel, the higher the demand for travel. And so this is what a rational choice model would assume about human behavior. But if we want to move beyond those assumptions about Homo economicus, we can use other perspectives such as social practice theory. And this is just one example of one type of analysis you could make using social practice theory. So social practice theory would prompt us to look at rebound effects as outcomes of routinized practices, everyday practices, such as commuting. So if we think about ride sharing as a commuting practice, we could see, okay, it's in competition with a less sustainable practice, which is driving with your own vehicle. Okay, great, that's super sustainable. But hold on, it might be in competition with another practice called trip chaining. It's pretty self-explanatory what that is. Basically, it's bundling, it would be bundling commuting travel with other practices like running errands. So using this perspective, we could actually see that travel demand has increased, yes, but we also understand that it's because the demand has decreased during commuting hours, however, has just shifted to traveling outside of those travel hours. Yes. Another problem that we need to address is that rebound effects, and probably because of its origin in energy economics, still remains largely confined to the context of the market. But we know that it is not only a market-based phenomenon, it's a complex social phenomenon that spans multiple domains of life. So it's not only changes in supply and demand triggered by economic stimuli like price changes. It's that, but it's also spanning our home domains, our household practices, work practices, and is actually not just triggered by economic stimuli, but an outcome of a complex of a web of complex interrelated elements, like psychological elements, or as we heard earlier from Jeroen's presentation, technology plays a large part. And it's not just quantitative changes, it's qualitative changes in how we spend our time, how we interact with our built environment, how we organize society. And I liked from Jeroen's presentation that he has on their incomplete list. This is an incomplete collection of icons here. This is just to illustrate that this is a very complex phenomenon, and we have to treat our definitions and our methods as such, and appreciate this diversity. And yes, yeah. So to bring it all back to the goals of this part of the project, we want to try to explain the human behavior and system structure, go beyond these rational choice models. We want to look at the individual level, but also the system level, like as Tim has mentioned, socio-technical systems and their relevance, cross-domain and transdisciplinary research, as well as I want to mention systems. It must align with systems thinking. And overall, to just give the debate about rebound effects more explanatory and descriptive power. And now you'll hear more from Igor about the next building block. Was I supposed to introduce you?
Thank you very much, Elise. So yeah, we have pretty big challenge to solve here. How do we actually expand our knowledge from the traditional way of understanding how humans take decision to the real way that humans take a decision and how this influences rebound effects. And this leads to the next step that is, okay, now we do understand. Now we have the mechanisms. Now we know that if A happens, probably it will lead to B, that will then result in C, that will have a rebound effect. But how do we put it all together? Because in real life, it's not about only one mechanism happening at a time, but actually several mechanisms happening at the same time and influencing the final outcome. And it's therefore extremely important to be able to model and simulate those complex systems so that we understand how this is going to take place. And Daniel is involved in this building block as well. He's taking too much of the day today, so he's not presenting anymore. But Igor, I want to invite you over. Igor is also a PhD student with us. He started in February. And he's one of our system dynamics masters.
Yeah. Just getting started. All right. Well, trying to build a little bit more on what Elise just presented now. We can say that there's plenty of studies on one or another dimension of rebound effects, but there's very little about the interrelations across them. And as she said, we do need this integrative view to be able to understand the phenomenon as a whole, right? And moreover, the sustainability strategies by designers and companies, they also affect all of these dimensions at the same time, right? So sometimes they're aimed at one or another dimension, but they end up impacting in all of them. Hence, a systems perspective is, we believe, what is needed here instead of a compartmentalized, silo-based perspective that dominates the literature until today. As a matter of fact, there's a recent paper from two members of our team here that demonstrates how this compartmentalized static approach is insufficient to describe rebound effects, and why a systems perspective is indeed needed in the context of sustainability transitions. So we cannot rely on models of one or the other discipline here, but we do need this integrated modeling perspective as well. So the current models that we have now, they account for the events, the rebound events that happen here and there. Maybe they help you see some of the patterns across these events, but they don't let you see the underlying structures and mental models that actually explain these events and patterns. So this is what we're trying to do here with the systems perspective. But what do we mean when we say, so these models are not only compartmentalized, but they're also static, right? What do we mean by that? We mean that by looking at the rebound effect, by measuring it or estimating it at a given point in time, you might get a very different result compared to looking at it further in the future or in another moment, right? And in the car sharing example that we've been using here, it's quite common that when a car sharing scheme starts, people still take care of the cars a little bit more in the very beginning because, you know, that's something new. There's something they care about. And then later they relax a little bit more and they stop taking care of the cars. And then the companies realize that they actually have to increase the replacement rate of the cars. And so there might be, in conjunction, all of these factors combined, there might be even an exponential or semi-exponential growth of the rebound effects happening in those cases. So if we look at the car sharing scheme in the second year, we might have a very different assessment compared to looking at it in the 6th year or 5th year or so. It might be in a totally different level of magnitude. What else do I need to say? Yeah. So it's clear that the complexity, and we were talking about this morning. I was in a table where I think you brought this, no, someone else brought this topic right in the networking event this morning, saying that, well, when we look at product design and efficiency strategies, the level of complexity and responsibility that is involved in assessing rebound effect is one, right? But when we turn to effectiveness strategies in the context of product services systems, the complexity is already much more overwhelming, right? Let alone the sufficiency strategies, the consideration of sufficiency strategies and social technical systems interventions when there is much less predictability and much more factors to be considered, right? So that's why we are adopting a modular approach in which not only the numerical and quantitative assumptions of our models can vary, but also the structural assumptions of our models. So that's something that modeling and simulation can help you with, and it's something we're building into the project. As a final goal, as our end game here is to provide to designers and innovators tools that can help us detect leverage points early on in the process and act accordingly, right? So if we look at this kind of situation here, we have ranges of possible rebound effects over time, right? Given some assumptions about what would be the strategy for a given product service system. What we want to be able to do is to let them simulate what ifs, right? What would happen if the strategy was different? Then we could maybe lower the rebound effects in some moments. We could reduce the total number of cars that is used for that car sharing scheme we've been talking about. So in essence, it's a sandbox or a test bed for designers to be projecting their rebound effects and making decisions based on it. Daniela will address this point a little bit more in the prevent building block. For now, that's it from my side. Looking forward to talking more in the networking. Thank you.
Brilliant. Now we know how to simulate rebound effects early on. We will probably have a much better estimation of how big or how small they are. We will know what are the points in the system that we can actually touch upon to try to change the design. Now we have all that we need to prevent. Yay. And how are we going to do that? So today, when we design the overall design process, and when we do it right, when we bring sustainability into the early stages that define 80% of the overall environmental impacts, we end up having sustainable solutions in the end. And we've been looking into those sustainable solutions in my first presentation, loads of examples across all the different areas. But we also know that they create rebound effects. So how can we design differently to actually avoid those rebound effects from happening at a first instance? We can, of course, decide to just tackle them after they happen. That's what happens today. But do we have time for it? Do we have time to design new solutions that will maybe take 3, 4, 5 years to be designed, then implement them, then see the rebound effects happening, and then trying to mitigate them? The earth might be a bit too warm when that happens. So I think we actually need to do it beforehand, and we need to bring that in the early phases of design again. And the way we propose to do it is to enable designers in the early phases to simulate how will their solution be accepted by the system, so to say. What will be the potential unintended consequences that they will bring? And on the basis of that, identify where are leverage points. Today, if you are to model those systems, it will take maybe at least a year to be able to come up with a good estimation. We don't have that time in the early stages of design. So we actually need to automate this process and to bring tools that can be used within this sweet spot during the design process. And the leverage points, as Igor just presented, will help us to test. So let's say that I have a brilliant idea of a solution that might address the rebound effect that I identified. We can test it. We can put them in the model, we can see how the model will react to it, and we can see whether they actually help solving the rebound effects, or maybe if they bring even more rebound effects, that would be terrible, right? And we can do that in the computer. We can do it by simulating, and we can do that before any material is extracted to produce that product or that product service system. And this leads us to what we aim as the final output of this project will be to create this database of what we call reboundless design strategies. So design strategies that are resilient to the occurrence of rebound effects and that we can implement either in isolation, depending on the system that we have at hand, or in combination. At that time, we'll be able to say how much design can actually help. Can it help us in resolving 100% of the problems? Probably not. We'll probably need a combination with policies, for instance, to try to make that happen. But then we will know, and we'll have a much better idea about how to move forward on the basis of that. And when that happens, then instead of developing design sustainable solutions at the end of a design process, we will actually have reboundless solutions, which are resilient to the occurrence of rebound effects, and that will actually help us to achieve the benefits that we expect to achieve with sustainability strategies. We might not be able to get to zero, that's why I have it there. But in 5 years, we can see, and I hope that for most of the solutions, we will actually be able to do it. And this is extremely important. I mean, imagine all the money that we put into developing new products, into developing new technologies, into funding amazing research projects, if they don't actually deliver on the results. Should we really do that? And this actually will help us to have this much better idea. And when we manage to do it, then we are going to move this bar from the current state of science down to the future state of science with the development of this reboundless design theory, which will become a course at DTU in the future. So that we can actually educate designers and engineers on how to design those reboundless solutions. And by doing that, we will, of course, not only be looking into science. I mean, we need science and we need hardcore science to do it. But we also need to translate that into practice. And we need to be able to use that in our day-to-day. Otherwise, again, if it's only in a bookshelf or in a folder in your computer, it will not make any difference. So we need to bring that to industry, and we'll be working actively to get requirements and to try to understand what do you exactly need in the early phases of design so that we can deliver upon it. And at that time, we will hopefully not only be able to solve problems with those 4 social needs that we are using as test beds during the project, but also into other areas. And healthcare is actually a really big one that we see here in Denmark that we really want to work upon, and maybe even apply for system projects to Reboundless so that we don't need to wait 5 years to actually start working in that area as well. And when that happens, we will actually bring one extra bubble in this graphic. This is basically representing the evolution of sustainability implementation in industry. Back then, when it started in the 70s, almost the same time that the picture from Earth was taken, companies were still having a reactive approach focused on end-of-pipe solutions, so just treating pollution after it's there, to a preventive approach in the 80s, where cleaner production actually became something really big, where we were trying to optimize our production processes to actually be able to create more output with less resources and less pollution. To a proactive approach, that's what we pray here at DTU, and that's where the world is today, looking into the whole life cycle of products and services and solutions and trying to minimize the impacts. That's where most of the efforts in relation to circular economy also are connected to bring one extra important element in here, which will be the systemic perspective based on this overall reboundless design. And by doing that and combining those 4 approaches for sustainability implementation in industry, we will hopefully be able to live within the planetary boundaries. Thank you very much.
Thank you very much, the 3 of you, Daniela, Elise, and Igor. I am very sure you have plenty of burning questions and you would like to challenge some of the points that we just showed you. So I will invite the 3 of you to please join me here in the plenary. Thanks. And I know quite some about the project, so maybe I should not be shooting the questions. And I invite you to raise your hands and share your questions. Well, we have 4. I will start here.
Thank you so much. And thank you for a lovely presentation. As Daniela knows, I have a background in psychology as well as in design and innovation. And of course, I think the combination of the 2 fields are very interesting. Which challenges have you met with combining these 2 quite different approaches? Maybe not so much design, but engineering is quite different than psychology. Have you had any discussions? Because I think there are some videnskabsteoretiske differences. Yeah.
Yes, there are. And I think that one of the Yes, great. I think that one of the biggest problems today is that they are by design not really taken into account at the same time. I think that it's really difficult for engineers to try to think how people will behave when their solutions are implemented. And we tend to have kind of this narrow view that this is the way I'm designing it to be used, And therefore, this is the way it's going to be used. Most of the user-oriented design research we have today are looking into requirements, what we say we want, instead of what we actually do with the things that we have at hand. And I think that bridging this gap is extremely important. And I think there's something really interesting that I've learned. I'm an engineer, right? But I've learned that we actually behave in very irrational ways, but in an extremely predictable way as well. We are all irrational in the very same way. And I think that understanding how we take those irrational decisions and trying to translate them into design rules can help us to get better decisions and to prevent the rebound effects from happening. That's why one of the areas we'll be focusing on in the project is on the behavioral economics, which tries to bridge those gaps and tries to actually see how we behave in reality.
I would just add one thing is that there are studies that explore psychological rebound effects, that's what they call them, or motivational rebound effects. And one thing, one element that the rebound research does include is the moral licensing effect, where we have a mental accounting of our moral credits. And when we do something we consider sustainable, then we can afford the mental credits to moral credits to do, I don't know, fly to Malaga or something. So it is in the literature, but I think it's one of the interesting parts of or contributions of this project is trying to somehow bridge these gaps and make sure that they're not being researched in the research silos of psychology rebound effects, energy rebound effects, whatever.
Do you see the possibility of the reboundless strategies eliminating some of the current concepts and current strategies, for example, circular strategies or sustainable strategies? So actually the reboundless strategies, is it another layer or is it going to replace those things and become the new golden standard? Or how do you see that?
Yeah, so we are still looking into efficiency strategies, into effectiveness strategies, and sufficiency strategies. Those are the three ways that we see that we can achieve sustainability in combination. We need to become more efficient, we need to become more effective, and we need to do that in a more sufficient way. So this doesn't replace, but what it does is to bring the extra layer to say, okay, implementing those strategies will create some unintended consequences that we need to know how to prevent. And this is where the reboundless design strategies are taking place. And it will probably not be something that it will be in a cookbook, because for different contexts, different reboundless strategies will be more relevant. And that's why we need the simulation models to try them out, to see how effective they're going to be before actually going there and implementing them.
Just to complement, I think what simulation can contribute to that is saying in what cases each strategy is more or less reboundless. So it's enriching this picture, making it more granular, right? So it's not going to replace, for instance, the concept of circular economy or effectiveness strategies, but it's going to show in what cases, in what contexts they are actually creating more or less rebound.
We have one more here.
Yes, maybe I'm going to stand up. Yeah, thank you very much to the three of you for the first insights on the research you had on this topic already. I really see the rebound effects as like the consequence of kind of like losing like this fear of limits that we have, like suddenly by having some efficiency gains, we're having a resource that is more abundant. So we tend to care a bit less about it. So we tend to consume more. So maybe the first question would be, isn't there something inherent, like natural when it comes to resources by consuming necessarily more when we have something that becomes less resource intensive? So isn't it something that we cannot avoid in the end? And then the second question will be, based on the first one, how are you sure that design can actually make a difference regarding this? Because there has been a lot of things said about, oh, let's look at the different design options that can help us to prevent the rebound effects. But how are you sure in the first place that those rebound effects can be avoided? Thank you.
Thank you. So to the first question, it might well be that when we see that resources are more available, we tend to use them with less care. But Jeroen actually gave a really good example of the feedback. If we know what are the consequences of using that resource more, we might change the way we take decisions. And there are actually studies showing that nudging, for instance, is an extremely effective strategy in trying to avoid this overconsumption of given products and materials and solutions. And probably nudging will be an important area that we'll be looking into for the reboundless design strategies. This is one way that we can do it. Another way is changing business models. So for instance, if we have a system in which we pay not to have access to use it, but you pay for the outcome that you are getting from this system, it's going to be a really clear connection between how much you are consuming and how much you are paying. And this might also change behavior in different situations. So those are those different types of strategies at a product, a business model level, but also at an overall system level. Imagine now that maybe instead of having a car sharing system, you have a full mobility system that a company is providing, where you can have access to a bicycle, to a car, to even plane tickets, depending on how far you are traveling. And then you have the right incentives in the system there to take the right decisions. So we believe that it is possible to change this normal instinct that we have. And from a design point of view, this is the biggest hypothesis of this project, that design is a strong leverage point. Actually, this is the first design project funded by the ERC. So I guess they are putting a bet on us as well to see what we can deliver. But it could well be that at the end of the project, after having all the simulation models, the conclusion is that, well, you know, design can only do 20% of the job, but it's already a really important knowledge to have so that we can try to see, okay, if not design alone, what else? And I mean, we also know that policy rebounds. There are loads of examples of policies that never achieved their expected outcome because of rebound effects, even policies that were trying to address rebound effects. And I guess it becomes a, yeah, how do you call it? One compounded rebound. Tim just created a new concept. So yeah, but that's what we'll be testing and trying to see during the project. But from all the cases that I've seen, I have a quite strong, what's the word for it? Conviction that design can actually be an extremely important leverage point.
Yes, there are quite some hands. We had one back there. And I will keep the time, so I'll let you know until when we can actually continue. So.
Yeah, thank you. Well, congratulations, first of all. And I don't know how to talk with this, so sorry.
It's difficult, isn't it?
It's very difficult. Actually, I mean, you've been talking about it throughout this time. So when I raised my hand, it was quite before you talked about. But I was curious because, I mean, you know, Sturman, right? And you know that all modelings and all the systems that we model are actually wrong, right? And it's very complicated to actually make something general, like validate something. So you're talking about testing, and you're talking also about like making models generalizable and transferable to other industries, which obviously is the aim that we all have, right? And the final goal. But what do you think are going to be your biggest challenges, and what kind of test are you willing to do or like to take in order to counteract these challenges? Because of course, like, it will happen.
Great. Well, it's a $1 billion question, but I'll try to I'll try to summarize a little bit. So one of the questions here is, what is the right level of abstraction to model this phenomenon, right? Because that is on itself a challenge here for us, right? Because we could build a model that addresses specifically, let's say, the car sharing case that we've been talking about. And we could then advance with that model to a level of validation according to the general quality standards of a model that could be perceived as a credible model for that specific case, right? And that's what most of the literature does, and that's the pathway that we are trying to avoid here. Again, there are many risks involved in this pathway, but what we're trying to build here is, and we've been already providing some insight through some of the publications, recent publications, is to first understand what is generalizable and what are the concepts and the level of abstraction that can be generalized, and then build on that to create variations, right? So it's a slightly different approach. But that's for sure a still an open question, right? To what extent, how specific will the contribution of our models be in the end, right? And we have a process designed for that. We'll be iterating this with industry players, with designers, precisely to find out something that can be useful, not right, as modelers say, to them, and at the same time keep a good level of scalability and modularity of the modeling that we're doing. Yeah.
Yes, there are quite some hands and not much time. We had an order, and we'll have time for one last one, but I will invite you to afterwards speak to each of them at all.
Thank you. First, congratulations for the project. So one of the questions that I have is that one criticism about behavioral economics is that nudging creates rebound effects, and it measures effects in the short term, while design may have effects on the long term. So how do you think about reconciling these two different time spans in your project?
Time horizons.
Well, I would just say something really quick about the explain building block. There you are. Because we intend to use behavioral economics as one theoretical perspective, but there are so many limitations with behavioral economics, and that's why we're incorporating different theoretical perspectives as well. That is the only point that I wanted to make. Maybe you wanted to say a bit more about that, about design.
Yeah, so I think that it's actually where we connect all the three building blocks together. Because if we have the simulation models, then we are going to be able to see whether this specific nudging strategy that we are trying to implement to prevent a rebound effect is having the effective that we want it to have or not, to a given context, in a given situation, for a given social need, and so forth. And that's why I mentioned to the previous question, there's no cookbook. One strategy that works in a given context, it's not certain to work in different areas. We always need to test. And it's about making those tests, trying to see how the behavior of the system reacts in relation to those, and then take the best decisions. I guess there will still be trade-offs. I mean, trade-offs is the 100 million question in design that we still don't know how to do really well. And I think that this will still bring an extra decision-making criteria in the mix.
Making tough decisions is very tough. There are plenty of questions, I know, but there will be time to talk to the panelists. For now, I invite you to give some claps, some hands for the Igor, Elise, Daniela. And Daniela will continue.
So moving forward, you might be asking yourself, what now, right? You've been hearing a lot about rebound effects, about the importance of it, about how we are actually planning to tackle it. And this is the launch of the project, but you'd feel really empty if we leave today without any results. So we do have a few results to share with you that we are actually really proud of. And the first one is a dashboard. Over the past 6 months or so, we've been doing a systematic literature review on all the papers available in the world to date dealing with rebound effects. And we've consolidated them all into a database. I say we because I feel part of that, but the mastermind behind this is Elise. She's done a brilliant job in bringing all of those cases together, instances of rebound effect together, classifying them according to a number of different criteria. Maria has also been of great help in putting that together. And for the ones that knows us, we love Excel sheets. And our Excels can be really, really big. But we wanted to share something more user-oriented with you today. And Jakob, where is Jakob? Yes. Jakob has been putting all of this knowledge into a dashboard in Power BI that is actually extremely powerful to give us an overview of the different rebound effect studies that has been out there, what they found out, where we see the biggest magnitude of rebound effects, and so on and so forth. You'll be able to try that out during the network break. We have a brilliant, huge touchscreen that you can play together with. But I wanted to make that one yellow to invite Elise to come over and give you a few insights from the dashboard so that you also know how to play when you get in there. Over to you, Elise.
So first, I want to say I don't love Excel, but it's very useful. After this systematic literature review, it makes my eyes hurt. But yeah, there's not so much to add, and I'm going to speed through this because we're short on time. But yeah, in total, there were the results were 1,413 papers. 412 of them got into the database, and there are 555 Rebound instances. And I know there's a lot to look at right now, but I would just bring your attention to a few of the points. First, I guess I should say what we extracted. So some of the themes from today, social needs areas, sustainability strategies, the rebound types, direct, economy-wide, indirect. Yes, also knowledge areas. We extracted a lot. So there's, I'm forgetting stuff, but it doesn't matter. So yeah, I think the first key insight I would point you towards is basically show you what is mostly out there. So the literature you can see is mostly direct rebound effects and economy-wide, mostly within the field of energy economics, and primarily within mobility and housing. There's also an other category which is not shown, so keep that in mind. Yeah, and also mostly efficiency, very much so, as you can see in the pie chart in the middle. Another interesting thing to look at is, as I mentioned, we have a lot of studies that look at rebound magnitude, that have estimated rebound magnitude. And you can see that at the top there, the median and the average. We included both because the range is incredibly wide. It's insane. So you can see there's already a difference of, yeah, it's twice as much when you take the average. The 47%, I wanted to draw your attention to that, just because it's interesting that it would align with Daniela's statistic from earlier, the 40%. And if our estimations are correct, then it's actually more. But yeah, let me just bring you to the rebound magnitude. So when you're exploring it on the dashboard, you'll be able to click on individual buttons to explore those fields a little bit more. And because of time, I'm not going to show you very much. But you can see already when we take all of the papers into account, the magnitude is the range is, like I said, it's insane. But you can click on, can you maybe click on consumables? So you can filter the displays and see how it varies. You can see when you press consumables, most of the units of analysis is at the product level and the product service systems level. You can just explore it yourself. We're running out of time, so enjoy. And if you have any questions about the systematic literature review, the database, you want to know more about these crazy backfire cases, then just talk to me or Maria or Jakob.
Yeah, so it's an impressive piece of work. We will continue working on it and keep that updated over time. And the idea is that it's available not only for us, but for all the people from industry, from government, from academia that are interested in building upon that. Because we really believe that if we are to reach the goals that we need to reach from a sustainability point of view, we need to help each other and we need to build it together. And that's the reason for why we are also planning to host this Rebound Effects Network. In the morning, we had a first session with loads of energy and engagement. So thanks for the ones that joined us this morning. And our main idea is that, I mean, if you look into the researchers on rebound effects today, there are many, but they are scattered. They are in all different types of universities, different types of governmental institutions and so forth. And there's nothing that connects them. There's no one single conference about rebound effects that we can go. And this is something that we actually want to establish. And Danielle has been the mastermind behind it, building upon a network that we are also launching today. So over to you, Danielle.
Yes. So if you want to access it now, you can also use that QR code, which is not there anymore. So we had, no, that's fine, it's fine. So we had the session this morning on building this network of people. We've been using the word hosted by us because it's not that the network is reboundless, but we will be using our resources, people, the best that we can, so we can contribute the discussion that now I think it's even clearer that it comes from many different perspectives and so on and so forth. So maybe we can contribute with that and bringing all the discussions, people, not only in terms of academic areas, but also the different players that, as we see, it's very important on the table. Yes. And then we're building this map. I can look at there, yes. And the map, it also follows the way that Daniela and all of us has been presenting. So we have the 3 different levels of design. We actually changed that a bit to include policy. So we have a product over there on the right, and then we have systems and we have policy, because we realize it's very important to connect hosts to our either policymakers or influence policymaking. And to be part of the network, you mainly respond to our questionnaire and you'll be added to the network. And now I just remember that the very important person again behind the network, Jakob, you again, we've been working together, but he did a very tough job of making our ideas into that. So thank you very much, Jakob, again. So you see, like, organizing information in a way that's meaningful. Jakob is your guy. And apart from these three big areas, for each of the areas, we have the 4 needs plus 1. We realized that healthcare was an important need as well to map. So we have a place there for healthcare. And I would just briefly show. So if we click on consumables, for instance, it will have down left, bottom left. Yes, cool. It will highlight those who are interested on consumables. Then you can get an overview. And if perhaps we want to know those people that design systems or are involved in systems, design, implementation, and so on, we can zoom in to the system down here. And then we will see those like-minded people that might have some common interests. So if we click in Daniela, twice perhaps, yeah, yes. We will know a bit more about her profile, the needs of interest, and apparently she's very much interested. She's interested in all these needs. I wonder why. And also on 9, we can know a bit more of what type of partnerships she's looking for. So perhaps you are looking for grant applications. Someone else is looking for grant applications in a moment of career to do that. Perhaps you can connect with her. And then we have LinkedIn, which always work when someone responds, and also other web page. So the idea is that everyone is very much welcome there, and we'll be building on that. We have been discussing quite much this morning on how to build on this first mapping to actually create a network that helps. Thanks.
And here you have all the animations. That was our plan B. In case it doesn't work, then we show with all of the print screens. And then we are, of course, always open to industrial and scientific collaborations. So if you found what we discussed today interesting, if you are curious about it, if you want to hear more, we are here for the next 5 years at least. So just reach out. Let's try to see how we can work together. What are the different opportunities that we can explore? As I mentioned, the way we do research is in close collaboration with who is actually doing that in practice. And let's just join forces, just reach out to us. How? LinkedIn. This is our main platform. If you are here today, probably you saw the event there, and we will keep sharing the news about the project in there, and also cases of rebound effects. Asgar, he's been taking pictures of us the entire day. He's over there. And he's the guy translating those cases that we have from academic, really heavy literature into something that is easy to understand so that we can create the awareness on rebound effects. So just do some advertisement, like us, share, comment, so that we get more traction there. There's also our website that will be evolving over time. So the database, for instance, will be available there with the dashboard, the network, and so forth. So keep an eye so that you can keep informed about what's coming up. And the logo. What does that mean? I told the people early in the morning about it, but let's try to do it together. Okay, the video is not working, so we are just gonna do it live. The first part of the area, if you can help pointing me, Igor, it actually represents the implementation of sustainable solutions, where we aim to go from a lower sustainability performance up to a higher sustainability performance. That's what we do when we are designing sustainable solutions. But then unintended consequences happen, the rebound effects that actually undermine the overall potential sustainability gains. Here it's representing about 40%, but we've heard that sometimes it can go to 7,000%. So the logo would look a bit different if we were to represent that. And what we do in Reboundless is actually to add the last really important bit there with the Reboundless design strategies that will actually help us to counterbalance the rebound effects so that we reach at least the same sustainability performance, but maybe even more. Something actually that they asked me during the interview was, how about secondary benefits? Couldn't that be that we are implementing some solutions that will actually be even better than we expect? And yes, and hopefully we can find them out and we can actually have a deformed logo, but to the other direction, not to the bottom. Yeah, so this project is being financed by the European Research Council. It's a consolidator grant, as they call it. It's running for the next 5 years. So plenty of opportunities to collaborate. And it's, of course, our very own DTU project. We have no other partners officially. This is the type of project. But again, we are open for collaborations. So maybe next time we can have many more logos here as well. Thank you.
Yes, it's that nice role that you have the honor to start and end. That's very nice. And we getting close to our ending. Before thanking you, I would like to thank those people. Actually, are you all around? Could you please come here? Matilde, Aska, Jakob, can you leave your role perhaps? Yes, you can, Maria, Igor. Yandre, I would invite you as well. I think you have to change. You have to change. Yeah. So you're here by heart, Daniela. So thank you all for all the nice work you did these last few days. And this is the team, by the way. Yeah. Yes, I didn't, sorry, Camila. So come here. Yes, yes, we have one more. Yes. Great. And we will be having some time, but before we have time, we actually have, how is it called? A surprise, I would say. This is a sort of a surprise. And I will invite Ellen. Ellen has some nice words to share with us now. We could, yes, we can. Yeah. Ellen, please.
Thank you. It's a fun tradition that you clap before I say anything. Maybe I'm a really critical voice. I'm not. Yeah, so it's not Daniela who invited me on stage. It's actually not anybody. I just wrote to Tim whether I could say a few words of appreciation, and he immediately applied, what a lovely idea. So, and it's hard to get Tim on email, but not when it's Daniela concerned. Then you can get him to reply immediately. Yeah, so I would like to offer a student perspective of why this is important. And yeah, so I have 3 reasons for saying a few words now. One is that I think that praise should be given when praise is due, and it is due in this case. And we are looking so much forward to to see what you are going to do. And I speak for all of us, all the students that are here, and also many of the students that are not here. And the other thing is that I know Daniela a bit during the years, or maybe more than a bit. And I know that Daniela really values a student perspective, and she's not only concerned with the future in terms of rebound effects, but also in terms of the people that are the future, if we may say so. And last of all, it's because it's exam season, and I'm the most creative when it's exam season. So I have also cleaned my apartment, and I wrote a song, and now I wrote this speech. Yeah, but Rebound, oh no, before we do that, I think I will introduce how I know Daniela and Tim. So I had the products and environmental issues course and really enjoyed that. And then I was looking for a bachelor thesis with my bachelor partner who just left. 2 bachelor partners actually. Ellen, yeah, right there. Yes, and Laura. And we were going to write something about bikes. And we went to a bike seminar, and I think it was very interesting, even though it was a bit chaotic. And it was with Klaus, and it was great. And then Ellen and Laura said, we don't want to write about bikes. And then I had to do a very awkward drawback with Klaus, which he forgave me eventually. But then we were på spanden, on the bucket, as you say in Danish. And then we asked Tim and Daniela in a hectic mail, can we write with you? And they were just like, yes, we have the perfect collaboration. It's with Jesper's Torvekøkken. And yeah, you can just start. So that was a big relief, but I don't know, I don't think we knew how lucky we were that Ellen and Laura didn't want to ride that bike thing with me. Because we were very lucky, because they put an immense amount of time in our project. They counsel us every week. and they put us to very high standards. In my primary school, I had a teacher who were a former policeman, and she also put me to very high standards, and you just grow from it. And that's the same with Tim and Daniela. They put us to really high standards, and sometimes you break down internally, but you also build yourself up, and then it all works out fine, turns out fine, and even better than fine. Yeah, so that's how I know them. And then I became colleagues with them on product life and environmental issues. And that was just lovely because they are also extremely nice colleagues. So you're very lucky to have them as colleagues. And of course, they are putting a really, really big effort in everything they do. So that was just an extremely nice experience. And the third thing was that not long ago, maybe 2 weeks ago, we had a seminar for design and innovation, which is called the 9 to 9 seminar, which is hosted every 6th year. And I participated with some of my peers. And I asked, because we were hosting a student presentation, Lucas was also there. And I asked Tim and Daniela what their perspectives would be, and they also attended the day. But that's because I think they are the future of design. So among other things, but very important part. So I wanted their perspective. Okay, so that was about me. So rebounds are sexy, right? I think we can all agree to that in this room, but maybe not in bigger societal discussions. And why is that, you might ask yourself? And I think it's because it goes sort of against an entrepreneurial trend and a societal trend, which is about, it's really captured by that Facebook slogan of moving fast and break things. And that's sort of a slogan that is nice to say, and I have coined it the graffiti desire, that you want a fast impact, you just want to tag the world with your impact, and then you can see your dent, and that's just satisfying. That's a urge that small children have, and it's an urge that big children have that goes to work. But I think you can say that they are rebellious and they are changing the world with these fast-paced inventions. But I think that you are no less rebellious and no less innovative, quite the opposite in your research, because it is also revolutionary and rebellious to change the pace of innovation and to really take your ethical responsibility very seriously, and not just satisfy your own desire to make a dent in the world. And yeah, brief. And we have also discussed that sustainability is so urgent. And I think I read a really good advice on a column, which were from a doctor that works with child labor. And she said, you know, the phrase, don't just stand there, act. But they had reversed it. So they were saying, don't just act, stand there. And I think that's also pretty accurate for this, because just because something is urgent doesn't mean that you shouldn't think about what you're doing. And you can hurry in a slow way. Yeah. Yeah, so I might not be the youngest of students. And I got that confirmed today when I was walking the halls of DTU, because there were some construction workers or handymen in the hallway, and one said to the other in Danish, "Lad nydelige dame komme forbi," which translates to "Let that lovely, not so young lady walk by." I'm 29, so it's not too bad, but I am young enough to really depend on solutions being developed within this field, because we are the generation that will feel the impact of what happens if we just do something with the head under our arm, as we say in Danish. Yeah. So rebound effects are a worthwhile endeavor. But who says that it should be DTU doing this, and who says that it should be Daniela and the Reboundless team? Well, I'm for one that says that. I think it should be you, and maybe also me. But besides, fortunately for the world, Daniela is not the only bright woman. Another of my role models is Margrethe Vestager, who's a Danish politician and now works for EU commissioner. And she's just awesome. But she has said that a revolution comes from a 20% new idea. And I think that sort of encaptures the brilliance of Team and Daniela's and Reboundless team's strategy, that you are not trying to, I mean, the allure is that you are dreamers, but you make the dream sound realistic. And I think that's so, that's such a thing to admire, that you do that, and that you lay the tracks for transformation of society, and you're doing it in a collaborative way, and not where you point your fingers at anybody, but you really want a pragmatic approach. And I think that's the only way to change the world. Yeah. So I think we should do a trefoldig hurra for Daniela and the Reboundless team. So Daniela and the Reboundless team, længe leve, hurra, 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 and then the long one, hurra! Yeah, that was everything. Oh no, it was not everything. I'm sorry. I have my assistant here. And we also have a card. And this card features a maze, because I was thinking yesterday what could personify what you do at Reboundless, and I hadn't seen your lovely logo, or at least haven't thought about it. So I drew a maze, and here at red footprints, you can see what other people do, and then you can see what Reboundless is going to do. And it's the long way, but it's the way out. So thank you.
I don't know if you want to say some words or.
I wasn't really expecting that, but it's really difficult to make me cry, and you did it. So thank you very much.
With all that said, I thank you all very much here in the audience online as well. I hope it was fruitful discussion, and I hope you still have some time to stick around with us. We'll be around for drinks and tapas and talking about and dashboards and network and all else. Thank you very much for today. Thanks.